Welcome to this session. This session, we are going to discuss about idempotent, periodic, idempotent, and involuntary matrices. So let's give the definitions. Start by idempotent matrix. So we say a matrix actually a square matrix A is said to be idempotent if A squared is given by A, that when you square a matrix, then you get the same matrix. And remember, A squared means A times A. So that's what defines an idempotent matrix. And remember, A squared means A times A. So e.g., try to check that if I have A, this matrix has 2, minus 2, minus 4, minus 1, 3, 4, 1, minus 2, minus 3. And then if you square, we have 2, minus 2, minus 4, minus 1, 3, 4, 1, minus 2, minus 3. Square means to multiply by itself. So 2, minus 2, minus 4, minus 1, 3, 4, 1, minus 2, minus 3. Show that if you carry out this matrix multiplication, we end up getting 2, minus 2, minus 4, and then minus 1, 3, 4, 1, minus 2, minus 3, which is A. So since A squared is A, then A is idempotent. So that's idempotent matrix. Next, let's define what we call a periodic matrix. So matrix, a square matrix, A is said to be periodic if A raised power k plus 1 is equals to A, where k is a positive integer. And then if k is the smallest positive integer, for which a raised power k plus 1 equals to a, then a is said to be of period k. So that's how we define a periodic matrix. So this is the key definition. And then where k is the least positive integer, or where k is a positive integer. Then from that definition, we can say if we choose k to be 1, we get a raised power 1 plus 1, which is a raised power 2 equals to k equals to a, and we call a an idempotent matrix. So idempotent is a special case of periodic matrix. And then second last one, let's discuss what we call nilpotent matrix. Nilpotent matrix. So we define this one as a square matrix A is nilpotent matrix if a raised power k is equals to 0. This 0 means zero matrix or null matrix, where k is a positive integer. So if, however, k is the least positive integer for which a power k is equals to 0 matrix, then k is called the index of the nilpotent matrix. That's what you have. So e.g., we say if we have a matrix A given by AB, B squared minus A squared minus A, B, then A squared will be AB, B squared minus A squared minus AB times AB, B squared minus A squared, AB And when you work out this, you get the null matrix of order 2. So this is what you're calling the zero matrix. So this A is an idempotent matrix whose index is 2. So that's what we have. And then next, let's discuss about what we call involuntary matrix. Now, a matrix A is called involuntary if the square of the matrix is equal to identity. So a matrix, a square matrix, A is called an involuntary matrix if A squared is I. This is the unit or identity matrix. So if you are able to get a matrix whose square is identity, then we call that square, that matrix involuntary matrix. So since I squared is the same as I, then unit or identity matrix is involuntary, because when you multiply by itself, you get an identity matrix. And let's also define what we call equal matrices. So when do we say that two matrices A and B are equal? So we say two matrices A and B are equal if and only if one, both A and B are of the same order or size. And then number two, the elements in the corresponding positions of both A and B are equal, i.e., if A is given by elements Aij and B is given by elements Bij, then Aij is equals to Bij. So, for example, if I have a matrix A given by 2, 3, 1, and 4, and I have a matrix B given by 2, 3, 1, and 4, then A equals to B. Because they have the same size and corresponding elements are equal. And then we have what we call inverse, and not inverse, singular matrix. This is a matrix. This is a square matrix. Whose determinant is 0. So e.g., if I have a matrix A given by 1, 2, 3, 6, then determinant of A is 1 by 6 minus 3 by 2, and this is 0. And lastly, let's define what we call invertible matrices. So a matrix, this is a matrix which has an inverse, a square matrix, which has an inverse, and this means that determinant is not equal to 0. So those are the definitions of those different types of matrices. Thank you.